Good morning everyone. This is Gausby from CSC department. My topic is ionic polarization. First we have to discuss introduction to ionic polarization. Ionic polarization refers to the distortion of the electron cloud of an ion in the presence of electric field. This phenomenon is crucial in understanding the behavior of ionic compounds in various environments. Ionic polarization plays a significant role in the properties of materials, including dielectric behavior and conductivity. Next, we have to discuss definition of ionic polarization. Ionic polarization occurs when the positive and negative charges within an ion are displaced due to external forces. This displacement leads to a temporary dipole moment within ion, affecting its interactions with other ions or molecules. The degree of polarization is influenced by strength of the electric field and the nature of the ions involved. Mechanism of ionic polarization. The mechanism involves the shifting of the electron cloud around the nucleus when an electric field is applied. The distortion is greater in larger ions with more closely held electrons, leading to higher polarizability. This process can be reversible, allowing the ions to return to their original state once the electric field is removed. Factors affecting ionic polarization. Several factors influence ionic polarization, including ionic size, charge, and surrounding medium. Larger ions tend to be more polarizable due to their diffuse electron clouds. This is the presence of other ions or polar molecules can be enhance or inhibit polarization effects. Polarizability. Polarizability is a measure how easily the electron cloud of an ion can be distorted. It varies significantly among different ions, with larger or more highly charged ions typically exhibiting higher polarizability. Understanding polarizability helps predict the behavior of ionic compounds in various chemical and physical constants. Ionic polarization in solids. In ionic solids, polarization can be significantly affect their mechanical and electrical properties. The alignment of polarizable ions in an electric field can be lead to phenomena such as a piezoelectricity. Ionic polarization is also important in determining the electric constant of ionic materials. Ionic polarization in liquids. In ionic liquids, polarization affects the mobility and interaction of ions in solution. The ability of ions to polarize can influence solubility and reaction rates in chemical process. Ionic polarization in liquids is also key factor in determining the viscosity of the solution. Applications of ionic polarization. Ionic polarization is essential in the development of capacitors and other electronic components. It plays a crucial role in the behavior of electrolytes used in batteries and fuel cells. Understanding ionic polarization helps in designing materials with specific and electrical and thermal properties. Ionic polarization in biological systems. Ionic polarization affects the behavior of ions in biological systems, influence nerve signal transmission. The polarization of ions is critical for function of cellular membranes and transport process. Changes in ionic polarization can have significant effects on biochemical reactions and cellular activities. Measurement of ionic polarization. Ionic polarization can be quantified using techniques such as dielectric spectroscopy. These techniques allows researchers to analyze and frequency dependent response of materials to electric fields. Accurate measurement of polarization is vital of development materials with tailored properties for specific applications. Challenges in ionic polarization research. Research in ionic polarization faces challenges related to the complexity of ionic interactions in various environments. Theoretical models must accurately account for effects of temperature, pressure, and composition. Experimental techniques must continue to evolve to provide more precise measurements in diverse settings. Thank you.